Hello students, today in this video we will discuss about energy. Before learning about energy, we should know what is work, because energy and work are relative terms. Work, what is work? Just see, when we are reading, we are writing, we are listening to music, whatever, but we are not doing any work according to physics. Because physics says that work is said to be done when a point of application of force moves a body through a displacement. That means when a force is applied on a body, it moves. Why we are talking about displacement? Why not distance? When a force is applied on an object or a body, it moves. And we are saying that it moves through a displacement. Why displacement? Then what is the basic difference between distance and displacement? We know that distance is a scalar quantity, whereas distance is a vector quantity. So why we are using the vector quantity, that is displacement over here? We can see that when a force is applied on a body, it is applying on a direction, in a specific direction. So if the body is moving in that specific direction, that means it is maintaining that direction, not only the magnitude. Okay, so according to this direction, we can classify force as work done by the force and work done against the force. What does these two terms means? Work done by the force means when a force is applied on an object and the object moves in the direction of the force. That means if we are pushing or pulling an object, we are applying a force. We know pull or push is a force. So if we pull or push an object, it will move in the direction in which the force is applied. That means if we push an object, it will move in that direction only. And if we pull an object, it will move towards me. That is, it is maintaining the direction in which the force is applied to that object. That's why a specific direction is applied. That's why we are using the term displacement in terms of distance. Work done by the force. So if we pull or push an object, the body or the object will move with the direction in which the force is acting. This is a perfect example or a simple example for work done by the force. Then what do you mean by work done against the force? How can it be possible that an object is experiencing a force and it is moving in the opposite direction of the force? Is it possible? Yes, it is possible. And this is known as the work done against the force. That means when a force is applied on an object and the object is moving in the opposite direction in which the force is acting. For an example, when we climb upstairs, that means our body weight is acting in the downward direction. That means towards the gravity. That is, every object is attracted towards the center of the earth by the force of gravitation. Okay, and now we are moving or climbing upstairs. That means the body or the object is experiencing a downward force and it is moving in the upward direction. That means the totally opposite direction. This is known as the work done against the force. That means the body is moving against the direction of the force. So this is work done against the force. And the angle, if we consider the angle between the direction of the force and the direction of the motion, it is completely 180 degree. That is in the opposite direction. So this is known as the work done against the force. Now we will discuss about a new term, no work force. We have already discussed about work done by the force and work done against the force. Now we will know a new term, that is no work force. The term itself signifies no work force means we will see two conditions where no work force is applied. Two conditions means, suppose we are applying or giving a force to an object. The object is not moving. Suppose we push a wall. We are giving force, enough force, but the wall is not moving. That means we are applying a force to the object or to the body, but the body does not displace. That means even if we are applying a force to the object, the body is not, or the object is not moving. That means no work is done. Okay, that means if force is applied and the body is not in motion, that means no work is said to be done. The next one, suppose if the direction of the motion and direction of the force bears a simple angle of 90 degree. That means if the direction of the motion and the direction of the force is perpendicular to each other, therefore no work force is said to be done. Why no work force is said to be done? Here we are saying about an angle. That means an angle is forming between the two directions. We know if the force is applied in an angular way, okay, the formula of work done will be W equals to F into S into cos theta. Okay, this is the formula of force, of calculating the force. Okay, when the force is applied in an angular direction, if the angle between the direction of the force and the direction of the motion is perpendicular, that is 90 degree, the magnitude of the force will be, the magnitude of the work done will be W is equal to F into S into cos theta. That means F into S into cos 90, and we know the value of cos 90 is 0. So if any of the condition, that means it may be force, it may be displacement, or it may be the angle, if any of the circumstances is 0, the whole work done will be 0. Therefore no work will said to be done. Suppose a coolie is lifting a luggage on his head. In this case, he is doing a work. Why he is doing a work? He is applying a force to lift the luggage, and the luggage is moving. The luggage is moving in the direction of the force in which the coolie is pulling the load. That means it is work done by the force. Now, the coolie is walking with the load on his head. In this time, he is not doing any work. Why he is not doing any work? Just now when he was lifting the load, we are saying that he is doing a work. And now when he is walking with the load on his head, now he is not doing any work. Why? The load or the luggage is experiencing a weight that is in the direction towards the Earth's gravity. Okay, that is in the downward direction, and the coolie is moving in a horizontal plane. See, the body is experiencing the weight, that is a force, in the downward direction. Okay, and the coolie is moving in the horizontal plane. Now see, an angle of 90 degrees forming between the two directions. Okay, now if the angle is 90 degree, we can say that the value of cos 90 is 0. Therefore, although the coolie is walking with the luggage on his head, he is not doing any work. So this is also no work force. Now, what are the factors on which work done is calculated? Okay, or what are the factors on which the work done depends? Work done basically depends on the magnitude of the force. That means how much force is applied to the body. Number 2, the displacement of the body. What displacement is it moving? And number 3, it's not very much important, but still the angle between the direction of the force and the direction of the motion. So these are the 3 factors. Now, what is the unit of work done? The unit of work done, first of all I have to know the factors. Here we will know the 2 factors, that is the magnitude of the force, and number 2, the displacement. Therefore, it is the product of force and displacement. Work is ultimately the product of force and displacement. This is the mathematical relation. The mathematical relation of work done is force into displacement. That is, when we will discuss about the SI unit or simply the unit of energy, we have to know the units of force as well as the displacement. The unit of force is Newton. The SI unit of force is Newton, and the SI unit of displacement is meter. Therefore, the product of the unit of force and the unit of displacement will be Newton meter. Therefore, the unit or the SI unit of work done is Newton meter. Now, what is the CGS unit of work? So, the CGS unit of force is dyne and the CGS unit of displacement is centimeter. Since work done is the product of force into displacement. Therefore, it is dyne into centimeter. That is dyne centimeter. Therefore, the CGS unit of work is dyne centimeter. So there is another term that is joule. We can use joule as the SI unit of work done. Okay, so the SI unit of work done is joule. Now let's discuss about energy. Now energy, we have already discussed that energy and work are relative terms. Why relative terms? What is energy? The capability or the ability to do work. That means how much work can be done. Okay, that is, it's also work. The amount of work, that's energy. That is how much work we are able to do. That is energy. So energy, the SI unit of energy is also joule, and the SI unit of the CGS unit of energy, we can say it is it's different unit. We can use different units of energy, that is a calorie, a kilocalorie. This is the bigger unit of calorie. These are the different units we use while expressing energy. So what is the basic difference between energy and work? The basic difference between work and energy is that work cannot be transformed into different forms, but energy can be transformed into various forms. Okay, we know that the law of conservation of energy. What do you mean by law of conservation of energy? The law of conservation of energy states that energy can neither be created nor be destroyed. That means we cannot create energy, or neither we can destroy energy, but energy can be transformed from one form to another form. That means there are various types of energy, and each type of energy can be converted to the other, but the sum total of the energy in the universe always remains constant. This is all about the law of conservation of energy. So I am repeating the law. The law of conservation of energy states that energy can neither be created nor be destroyed, but it can be transferred from one form to energy. Now, what are the different types of energy? There are various types of energy. It may be mechanical energy, light energy, heat energy, chemical energy, nuclear energy, tidal energy, and so on, magnetic energy, and there are various types of energy, and they are interconvertible. What do you mean by interconvertible? That means they can be converted from one form to another. Just see some of the examples of the conversion of energy. Suppose switching on a fan. When we switch on a fan, the fan starts rotating. That means the electrical energy is converted to the mechanical energy. Okay, now we know that photosynthesis, plants make their food by the process of photosynthesis. What is photosynthesis? That means plants require the solar energy to prepare their food. Therefore, the solar energy is converted to the chemical energy. The chemical energy is the stored energy that is in the food. Okay, now we are switching on a switch and the light glows. Okay, that means electrical energy is converted to light energy. Bursting of firecrackers. The firecrackers contains different types of chemical. Okay, and now when we are bursting or burning the firecracker, it produces sound, it produces heat, it produces light. Therefore, the chemical energy is converted into heat energy, light energy, sound energy. So these are the different forms or the different types of energy that may be converted into the other types. Okay. Now we can take an example. Suppose dam. Okay, water is stored in a dam, and therefore this water is used to generate electricity. Therefore, the stored energy, it is a type of mechanical energy. We can say this is potential energy. We are discussing about this potential energy, but the stored energy or the potential energy is converted to electrical energy. We are charging a battery of the phone. That means the electrical energy is converted to chemical energy. Now, only the battery contains the chemical stored in it. And when we are using the battery in different electronic devices, that stored energy or the chemical energy is converted to the electrical energy. So these are the different types of energy that are interconvertible to each other. That means each type of energy can be converted to the other type. But the entire energy in the universe is always constant. That's the law of conservation of energy. Now, just now we have used the term potential energy. What is potential energy? We know mechanical energy. Mechanical energy. What is mechanical energy? The energy possessed by a body by virtue of its motion or configuration. What is configuration? We know motion. Motion means when a body is moving. Then it must be rest. But why we are saying configuration? Not only rest. It is the energy possessed by a body by virtue of its configuration also. Configuration means shape and size of the body. Therefore, mechanical energy stands for the body if it is in motion or if it is in rest. And if it is in rest, it is also mentioning about the configuration, that is the shape and size of the object or the body. Now, mechanical energy can be classified into two types. One is the kinetic energy and the second is the potential energy. What is kinetic energy? The energy possessed by a body in motion. That means the energy possessed by a body by virtue of its motion. That means when a body is in motion, then its energy is considered to be the kinetic energy. We have read about the kinetic theory of matters in previous videos. Kinetic energy or the kinetic theory means, kinetic energy means when the molecules are in motion, we say it is kinetic theory. Similarly, kinetic energy stands for the energy possessed by a body by virtue of its motion. Okay, then what is potential energy? That means the energy possessed by a body when it is in rest. Yes, that's it. When a body is in rest, the energy possessed by the body is considered to be the potential energy. Okay, now the potential energy can also be classified into two forms. One is the elastic potential and second is the gravitational potential energy. So what is the differences between the gravitational potential energy and the elastic potential energy? Both are the type of potential energy. Now we can define potential energy, that means the gravitational potential energy as well as the elastic potential energy, in two different ways. What are they? The energy possessed by a body by virtue of its position. Therefore, at what position or at which position the body is resting, that is the gravitational potential energy. That means at which height the body is placed. And what do you mean by elastic potential energy? Elastic potential energy means the energy possessed by a body by virtue of its configuration. That means the shape and size of the body. If the shape and size of the body changes, its energy also changes. So this is the basic differences between the elastic potential as well as the gravitational potential energy. Now, we will discuss about the formulas, how to calculate the kinetic energy as well as the potential energy. The formula of calculating kinetic energy is half mv square. Half into m into v square. What does this alphabet signifies? M stands for the mass of the body and v stands for the velocity of the body. Since the body is moving, the body is in motion, it should have its velocity. Therefore, the kinetic energy depends on the mass of the body as well as its velocity. And the product of mass and the square of the velocity multiplied with half is known as the kinetic energy. That is the mathematical expression for calculating kinetic energy. If you want to know the derivation, how this formula, that is half mv square, comes from, you can see a different video. I will give a link in the description box. We have already discussed about this in a separate video. Okay, now the potential energy. At first, we will compare energy with work, and you will easily see how we can derive the formula. Okay, what is work? That means what is the mathematical expression of work? Work means F into S. That is the product of force and displacement. Now, if we want to derive the formula of potential energy, that is basically the gravitational potential energy. That means the body is placed at certain height. Okay, here the displacement. Suppose we are discussing about a free falling body. That means when a body falls in the direction of the gravity, or a body is placed somewhere at a certain height. Okay, therefore now the displacement is height in this case. Okay, work done means force into displacement. Here the force is the weight of the body. Weight is also a type of force, we know that. What is weight? Weight is the force by which every object is attracted towards the center of the earth. That means weight is also a force. Now, in case of potential energy or the gravitational potential energy, the force is the weight, okay, and the displacement is the height at which the body is placed. Done? Therefore, we can say that the potential energy is equal to weight into the displacement. That is the weight into the height. Okay, weight means the product of mass and acceleration due to gravity. That means we can replace weight with m into g. That is mass into acceleration due to gravity. Therefore, the mathematical expression for energy or potential energy will be m into g into h. So this is the basic formula of finding the potential energy. Now, you can say that what are the factors on which the potential energy depends on? So there are three factors. Potential energy depends on the three factors. Number one, the mass of the body. Number two, the acceleration due to gravity. And number three, the height at which it is placed. Now, a question may arise that what happens to the potential energy if the mass is doubled? If the mass is doubled, lastly we have discussed the formula mgh. Now, in case of mass, that is m, we will substitute 2m, twice m, that is the mass is doubled. If the mass is doubled, therefore the energy will be 2m into g into h, that is twice of mgh. That means if the mass is doubled, the potential energy will also be doubled. Okay, similarly, if the height is doubled, the potential energies will also be doubled. Okay, so these are the factors. This question may come. I have missed a very important part, that is from the kinetic energy. What is that one? Now, if the mass is doubled, how will the kinetic energy changes? This is a very common question that can come in exam. If the mass is doubled, the kinetic energy will also be doubled. Okay, and now if the velocity is doubled, how will the kinetic energy changes? See, the formula is half into m into v square. Okay, now if we substitute v with 2v, that means the velocity is doubled. Since the velocity is doubled, therefore v square will be 4v square. Okay, that will be half into m into 4v square. That means if the velocity is doubled, the kinetic energy will increase 4 times. Okay, so this is how we can derive or we can discuss about the factors of kinetic energy and potential energy. What are the basic differences between kinetic energy and potential energy? Can this kinetic energy and potential energy be convertible? That means it can be converted to one form to another. Yes, it can be converted from one form to another, or it can be transformed from one form to another. How? See, we can take an example of a bowstring. Suppose we stretch a bowstring. Okay, now the bowstring is in a stretched condition. That means the shape is changing. That means the configuration is changing. When the configuration is changing, therefore it's totally the potential energy, the elastic potential energy, but the bowstring is not moving right now. It is just in the stretched condition. That means its configuration is changing. That is, it is totally the potential energy. Now if we release the string, okay, the string along with the bow will start moving. That means the stretched form of energy, that is the potential energy, will be converted to kinetic energy when the bow is moving. So this is how the potential energy is converting to kinetic energy, and vice versa. So potential energy can be converted to kinetic energy, as well as kinetic energy can also be converted to potential energy. Winding of a spring If we compress a spring, its shape is changing. That means its dimension is changing, its configuration is changing, and it's in a rest position. Therefore, it is having the stored energy or the potential energy, that is the elastic potential energy. And now if we release the spring will automatically move, that is, it will convert into its kinetic energy. Therefore, we can say that potential energy and kinetic energy are also interconvertible, but the total kinetic energy and potential energy, the sum of the kinetic energy and potential energy is always constant. We can see a different example, a separate example, totally a separate example to discuss about the law of conservation of energy according with kinetic as well as potential energy. Suppose a pendulum. We know what the pendulum is. When the pendulum is in a rest position, we can say that the pendulum is in the mean position. Okay. Now, when the pendulum starts oscillating, that means from the mean position, it is oscillating to the extreme position. Okay. After reaching the extreme position, it is again returning to its mean position. Okay. After reaching the mean position, it will again move towards its another extreme position. And after reaching that extreme position, it will have a tendency to return back to its mean position. And this whole process is known as one oscillation or one vibration. We consider oscillation in case of a simple pendulum. Now, so how can we relate the law of conservation of energy with the simple pendulum, the motion of a simple pendulum? So we can say that the whole body or the bob of the pendulum is in motion. Therefore, if we want to relate, we can say it is kinetic energy. But no, there is a law of conservation of energy. How can this law of conservation of energy be related? Now just see, when the pendulum is in the mean position, okay, it has a tendency to move towards its either extreme position. Therefore, it has a tendency, or it's already started moving. Therefore, it will have the maximum kinetic energy, and the potential energy in this point is minimum. But now, when it's moving towards its either extreme position, that means when this is the mean position and it is oscillating or traveling to its extreme position, and suppose this is its extreme position, okay, and while reaching or on reaching the extreme position for a fraction of second also, it will come to rest. At that point, when the body is at rest or the object is at rest, therefore the potential energy will be maximum, and in this case the kinetic energy will be minimum, and this will repeat itself in both the extreme position. Okay, therefore we can conclude that the kinetic energy is maximum at the mean position, whereas the potential energy is minimum. Whereas in both the extreme positions, the potential energy is maximum, whereas the kinetic energy is minimum. But the sum total of the kinetic energy and potential energy at each point are constant. That means they are obeying the law of conservation of energy. So this is all about work and energy. Thank you, students.